Hi, welcome to ExamPadi. Our topic today is counting in base 2. In this lesson, we will 1. Explain number bases and what it connotes. 2. Learn how to convert from base 10 to base 2 and vice versa. Do you have an idea what counting in base 2 entails? They are the same as binary numbers, essential to computing, as all the data that runs through your phone or computer is binary. Now let's bring it up. Binary, also known as base 2, is a counting system that uses only two numbers for each place, 0 and 1. In binary, you need a second place to represent a higher number than 1. Let's briefly look at the history of counting in base 2. In mathematics, a base or radix is the number of different digits or a combination of digits and letters that a counting system uses to represent numbers. For example, the most common base used today is the decimal system because DEC means 10. It uses the 10 digits from 0 to 9. Most people assume we often use base 10 because we have 10 fingers. A base can be any whole number bigger than 0. If it were 0, then there will be no digits. The base of a number may be written next to the number. For instance, 23 subscript of 8 means 23 in base 8, which equals to 19 in base 10. This image shows the number of base digits used and their names, ranging from binary to vigesimal. Counting in groups of 2s, also known as binary. Counting in 2s is essential for understanding binary representation and other mathematical concepts. A binary number is made up of only zeros and ones. An example is 110100. There is no 2, 3, 4, 5, 6, 7, 8, or 9 in binary. A bit is a single binary digit. The number above has 6 bits. Binary numbers have many uses in mathematics and beyond. As a matter of fact, the digital world uses binary digits. To show that a number is binary, follow it with a little tool like this: 101 subscript of 2. This way, people will not think it is the decimal number, that is 101 in the subscript of 2. How then do we count using binary? We start at 0, then 1. But if there is no symbol for 2, what do? We count in decimals starting at 0. Count 1, 2, 3, 4, 5, 6, 7, 8, and then 9, which is the last digit in decimal. So we start back at 0 again, but add 1 on the left hand side. Let's discuss binary place values or binary place position. In the decimal system, there are ones, tens, hundreds, and so on. In binary, there are ones, twos, fours, and so on, as shown in this image. In this image, we have 1101.101. On our left hand side, we have the numbers before the decimal. On our right hand side, we have the numbers after the decimal. The numbers before the decimals have 1s, 2s, 4s, and 8s, while the number after the decimal carries a power of 1/2, that is half, 1/4, 1/4, and 1/8, which is 1/8. On the left hand side, the numbers are 2 times bigger, while on the right hand side, the numbers are 2 times smaller. How then do we convert numbers in base 10 to base 2? Before we do that, we need to compare the decimal and binary. In the decimal, we have numbers that can range from 0 to 15. But in binary, we have numbers that can range from 0 to 111. Numbers in base 10 are sometimes referred to as decimal numbers or denary. Decimal numbers can be converted to binaries by dividing the number repeatedly by 2 and the remainders written on the right column until the last number is 0. Let's take a look at a few examples. 1. Express 27 base 10 as a binary number. 2. Express 140 base 10 as a binary number. Solution. Expressing 27 base 10 as a binary number simply means that we are to divide 27 in base 10 by 2, since binary means 2, by using the long division method. 2 in 27 is 13 remainder 1. 2 in 13 is 6 remainder 1. 2 in 13 is 6 remainder 1. 2 in 6 is 3 remainder 0. 2 in 3 is 1 remainder 1. And 2 in 1 is 0 remainder 1. Using the upward arrow, our answer will be 11011. That is, 27 base 10 will give us 11011 in binary. Solution to example number 2. Express 140 base 10 as a binary number. Using the same method, 2 in 140 is 70 remainder 0. 2 in 70 is 35 remainder 0. 2 in 35 is 17 remainder 1. 2 in 17 is 8 remainder 1. 2 in 8 is 4 remainder 0. 2 in 4 is 2 remainder 0. 2 in 2 is 1 remainder 0. And 2 in 1 is 0 remainder 1. Moving the arrow upward, we have 10001100. That is, 140 base 10 is equals to 10001100 in base 2. We've converted from base 10 to base 2. Now let's look at how to convert numbers in base 2 to base 10. When binary numbers are expressed as a sum of a multiple of a power of 2, the sum of the values of those powers is a number in base 10. Hence, to convert numbers in base 2, that is binary numbers, to numbers in base 10, we express the numbers as sums of multiples of 2. Let's take a look at a few examples. Example 1. Convert 1011 base 2 to a number in base 10. Solution. 1011 base 2 equals 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. Here, we don't have any decimal, which means starting from our left-hand side, we name our powers from 0 down to 3. That is, we have 1 times 2 raised to the power of 3 plus 0 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 and plus 1 times 2 raised to the power of 0. This gives 1 times 8, which means 2 raised to the power of 3 equals 2 times 2 times 2, which gives 8, plus 0 times 4, that is 2 times 2 gives 4, plus 1 times 2, that is 2 raised to the power of 1, 2 in one place is 2, plus 1 times 1, that is anything raised to the power of 0 gives 1. And that gives us 8 plus 0 plus 2 plus 1, which equals 11 base 10. So we can say 1011 base 2 equals 11 base 10. Example 2. Convert 1001 base 2 to base 10. Applying the same method, 1001 base 2. The first thing we need to do is we need to name the powers, starting from the left-hand side to the right-hand side. From the left-hand side, 0, 1, 2, 3. That is 1 times 2 raised to the power of 3 plus 0 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. 1 times 8, that is 2 raised to the power of 3 gives us 8, plus 0 times 4, 2 raised to the power of 2 gives us 4, plus 0 times 1, 2 raised to the power of 1 gives us 2, plus 1 times 1, as anything raised to the power of 0 gives 1. This equals 8 plus 0 plus 0 plus 1, which equals 9 base 10. Therefore, 1001 base 2 equals 9 base 10. We have come to the end of today's lesson. Here are a few questions to assess yourself on the just concluded lesson. 1. Convert the following base 10 numbers into binary. A. 62, B. 23, C. 93, and D. 74. 2. Convert the following binary numbers into base 10. A. 1011, B. 10101, C. 10010, and D. 1100. Thank you for learning about counting in base 2 with me. See you in our next video.